Hey, thank you. So just a little bit more about the program. We're sort of split into 4 sessions, each with 3 presentations. So hopefully it's nice and bite-sized. So after the first session, we'll have a coffee and then an hour's lunch break before the final 2 sessions this afternoon. So hopefully, if you have an opportunity to scan down there, there is some really good stuff on the program I'd like to share with you. Okay, so that was my introductions. Really, I'd like to introduce our first speaker, and today for our keynote, we've got Malin Klitborg from the Swedish Mapping, Cadastral and Land Registration Authority, and she's come to talk to us today about the use of standardized frameworks in the digitization of the planning and building process. Now, this is something that has been an interest to us in the UK. We've got a very fragmented planning and building process in the UK. So I'm really interested to see how Malin is able to take the data and improve that system. So thank you very much, Malin.
Thank you. Thank you for having me. I'm really pleased to see that all of you got up this morning and just to come here and listen to this. So I'm very grateful. How many of you are further away than Europe? None? Yes. You're from? Australia. Korea? Malaysia? US? Lovely. You have come the furthest. Very welcome to Sweden. We have prepared the weather just for you. Otherwise, it's been mostly brown and gray the couple of last weeks, but today it's lovely outside, crispy. Okay, the use of standardized framework in digitization of the planning and building process. This is kind of a trial to see, could we get one of the issues in the society, use standardization and try to get this to look the same in Sweden. And for the purpose of the digitization, we have the government who has been given a task to Lantmäteriet and to Boverket, who are the planning and building authority. And what they're in the Planning and Building Act is regulating the way you are able to use water and ground when building a society. And that should be made in a way that we get sustainability in the future. And as all of us know, sustainability is one of our main tasks to realize. And when we're working with sustainability, we know that if we use digitization, we will be able to do more, because we live in a very complex system. And to be able to handle that complex system, we need to use more data, and we need to be able to put that together in the system and use the efforts of the digitalization and digital ways of working to plan in the future. So if we put these two together, the task for just doing the planning and building together with digitalization, we say that we will reach more efficiency in the processes. We will have a higher democracy because you can share what you're doing with society and the people living in the country. We have, for example, down in Gothenburg, they are traveling with small buses into societies where there is a detailed planning going on. They take the bus, they go out in the 3D images showing for the people living there, and they can give their reasons back, which is meeting society where they are at the time when they have the time to meet you as well. Availability. We often talk in Sweden about those who are left out if you go into the digitalized world, those who can't handle a computer. But on the other hand, while using our computers or telephones, we also get a higher availability because you can reach it 24 hours of the day. You can go in whenever you want. You can zoom in, you can zoom out, you can click to what you need. So every coin has two sides. Legally, the legal certainty today, as you said, we have 290 municipalities, and each and every one is doing their own way of keeping this regulation up, so we can see differences between the municipalities. And as we go into digitalization of the process and the information, we get a more standardized way of doing also the decision making, which will give us a more legal certainty. And the last one, reduced costs. And I'm not saying that we will get a cheaper way of doing the planning and building, because we will probably just move the money into working with digital ways of doing it. If you look into your own organizations, you probably haven't been cheaper when you put computers in work. It's still the same square, but you move where you put your money. But if we work together, at least the investment in digitalization, if we do it one time at a centralized way instead of in 290 municipalities and 400 authorities. And that's probably also the only way we will be able to reach the goal, because each and every one on their own do not have the capability to go digital. So it's one of those. The other goal that government puts up, and I'm sure yours as well, this is a lot from EU, is all about the innovation and growth in economics, how to use the data as a new gold and make it possible for everyone. There is a new act coming up now where how can we share data more, and can we do it by law? And if we put this one on, then we go to the innovation and growth. And all of these three parts need to work together in the system that we put up. So the overall vision that we've been working with is, this is supposed to be one way of showing the planning and building process, which says that from when you have an idea, I want to build a house, until you can move in. It's a circular system of information exchange. And today in Sweden, as well as I guess in very many other countries, when you do the detailed planning, that's one apartment in the municipality, and when they are done, they will store the data and it will be left there. And then you go into the next step and you will store your data and it will be left. So what we say is, we need to make sure that everyone can reach this data all over the process all the time, and that the data is all evolving through the process, so that the data can handle all the needs from the entire process as well. To be able to work digital in the process, we need to have the e-services for citizens. And here as well, we do not have a Swedish standard way. So if you're a big builder of houses, you cannot go to several municipalities and apply for building permits, because it's so different systems. And we do not even have the ability for someone within a company to use your digital identification, since it's connected to you as a person. And today, in the analog way, the person who can ask for a building permission can be someone hired at a company. But when we go into the digital world, we are more squared, which means that the only one who could do the digital identification is the owner of the company. And we cannot have the owner of NCC or Skanska who should put their personal digital identification into every building permit in the country. So that's something we still have to solve. Also, administrative support for administrators. Also here, the municipalities are building their own systems. But what we have seen is that there are mainly only 4 big actors on the market to help the municipalities. So by working with those, we can reach standardization in a faster way than if we should work with all 290 municipalities. So that's a shortcut. Then we need to understand why do we do things we do with the data? One thing is, and once we have made the decision, we will put data into a long-term preservation. And that is for us to be able to, 10 years from now, 50 years from now, be able to say, we made the decision on these facts, and that's the entire act. And that's one thing. That's not the smart data. That's the legal data. Which needs to be able to be held digital as well, because we won't be able to store it otherwise. We also know that from this process, we always will have data we cannot share digitally, and we need to handle that as well. We still have the briefcases and the locked doors. But for the data that comes out of these decisions, if we put that into just data themes and pure data, because the act is something which we put down into the long term, that's the entire stock of papers and investigations and everything. But if we squeeze them into thin pieces and say, this is a data sets we need, and those data sets we now publish into this platform, and the sharing is from these standardized specifications that we have been working with together with the system developers and the municipalities and everyone. And those standards are built on the standards we have worked with SIS for many years, and we put in place all that we've been talking about. So now this is being built into the system finally. But we also use centralization as one way of making the standard comes real. We tried for the detailed planning to just put out a standardized way, and we let 10 different persons create the data, and it didn't look the same because we are still in the very beginning of something. We need to be able to try this out. We need to use it for a couple of years, and then I think we will be mature enough to put it into standards, and it would look the same because we start to look at it at the same way. But still, if we talk about this kind of data, it will look very different because we have so many different ways of having our interpretation of what this should lead to. So we need decentralization in this early stage, is our conclusion. But in this platform, Lantmäteriet is not putting a register. We do not build a register. We just work on behalf of the municipalities and facilitating the transfer of data. And for them to be able to use our service, they need to follow the specification. So this is a soft system. And they do it because we said, you have the responsibility for the Inspire, and we will do that Inspire if you just put the data through us. So we soft kind of cheating the municipalities to do as we want, you can call it. And what we want to create with all those data themes, and we see the data sets will probably around 150, 200, maybe 300 before we're done. Because now we want to make these data sets so small that we get down to where it's really the tiny pieces in the Lego puzzles that can fit in every purpose. And then we will have this digital twin. We want it to be in 3D. Many people want it in 4D, of course, with time escalating. So once we have this, we will be able to see the city in the planning and building process as a system. Today, when you do the planning and building, you look at your squared view, which means we don't get it put into the system, and that's why we can't see, oh, we couldn't predict that this should happen if we built over here. Well, if we get this data together and we can do the simulations that we need to do, we won't be able to say we didn't know anymore. So we need the facts, and we need to do the decisions on facts. But also, when we publish the data from the process into the platform, we also, by security reasons, check that data for aggregation. You know where we all are in society right now. Everything that were open for a while is now getting closed down. So with the data, each data set, we make sure that when we create them, we don't use personal data. We don't use text strings because we can't check that. And also we do a test for what happens when we put all this data from all these municipalities together. Does it occur new ways of using the data then that could be not secure for Sweden? And for example, for the detailed plans, we have been forced to take some of the smallest attributes away, so they are not shown in the national way of showing them. But it's good enough to do these kinds of things that we need to do. And still, once we have got this standardization, you can still go back to the municipality, and within the municipality, use the more detailed data. So this is driving standardization, but also getting the data out for innovation. And once we got into working in another way of looking at how to plan society, we see that then we will be able to change the entire wheel of how we plan, which means that we will probably work more with an updated twin of the city. And from that twin, we will have to make decisions when we see changes or we need changes, instead of doing this long-term planning, medium-term planning, and building permit. It will be more in the system. Now we're way ahead, but that's the vision, and that's what we're aiming for. The ambition we have with the data then, it needs to be open data to be able to be used in innovation. And the specifications that we have been creating, we want to give us the nationally interoperable, combinable and exchangeable standardized data, you know, all those buzzwords. How do we create these data sets so that the party taking using the data don't have to do the big work of putting it together? Because today it's very various, and also today we have the same data that we have in one register at one authority is also kept by another authority in another register. And when you look at those two data sets, it's not the same. Still, both are authority data, but we do not know which one is the correct one to use. So that's also one of the things, to be able to do this as good as possible. We want to make sure that there is only one register at one authority for each data set. Stop storing that, and that means we have to be able to stop downloading. We need to be able to use in the services. And that's mainly about trust. I had a conversation just on the way over here where our government wants us to build just another register and another register and another register with data that we should collect from other authorities. And then the question will be, okay, what is the true source of the data? It provides conditions for national digital twin, and here Helene has made a tremendous work with the help me, I was going to say 3D. Yeah, for the building where we're working with the geometry for 3D. How thorough should that be to be able to show the buildings in the right as real as possible, but without revealing where we have, for example, big air intakes or other things that we need to protect. So that has been quite a task, and I don't know if we're quite there yet. And in the same way, we also connect to the geodata. We make it possible to link Word documents and other things you need in the process, so that all these could be gathered together, which means that geodata, we have the built-in security. I'm going to get back. I'm have it in one. I just do it like this. Also, once only principle, only one register. It should be it should secure the vision with data-driven public administration and innovation and growth. And also, we have built this platform because we think that we need to be able to get access of the aggregated data, which should be secured, and it should be an easy access to open data, and it also creates an opportunity for Lantmäteriet. When we lived in the open society, we talked about, oh, just create open data, put it in a portal. Everyone can get it. If we do that, we have no check of security. And also, what we want to do is to people to connect to our services. And if lots of people are connected to our services and we do not know who's on the other side and we cannot communicate with them, we do not have a business agreement. We need to be able to get in contact with those who are connected, so we can tell them 6 months ahead, hey, watch out, something new is coming. And that's why I think this portal solution won't do the work. It's a good thing of finding data, but it won't do the work that we need. So when we say specifications, what do we mean? What is which specification, where in the... And we have been working with different specifications, but it's from the same data model, but for different use. The bottom of the data model is the same, and that's the root model. And that's in the information specification is for making sure that when the municipalities create data, everything needed is there. And that's the main first one we do. Then we have the data product specification for delivering to the national geodata platform. It's mainly the same, but it's been washed for those open data permission. But it's still from the same in the bottom. Then we have the specification for delivery, for delivery to customers. That is from the platform to customers. Then we have the delivery for the platform. And we also have, since what we have in the platform is reference information, so you can go in and you can search attributes. So we need also to have this specification. How do I reach each referred data part? And also the archive specification. And this has also been a big discussion. How should we be able to archive all this? And right now, Boverket has put in a report, and together with archive authorities, we've been looking into how should this be done. And now we have an additional information model which should be attached. And if that's good enough, it should be able to be used on every data set. It shouldn't differ. So that's what we try to do. To set those standardized specification, we have an information architecture and technical framework. This is the way we do the specifications. And I don't think you should read all this. The framework contains of 5 parts. It's some introduction and basic principles. It's the resource models, and resource models are those tiny models that should be used in every data set, like the geometry model, like the reference model, like the archive model. And these we call reference models. And right now we have a really hard time to sell this in to other authorities. Because if you go to the e-health area, and when you work with e-health, you probably need to refer to a geographical space from time to time. And then we want it to be by law that wherever you work within authorities, you should make the georeference in the same way so that we find the same spot. And we're not quite there yet. Everyone on their own. We have one for modeling and specifications, how to do the work. We have one for technical realization, and we work with OGC standards. I saw that someone was going to talk about those this afternoon, so then you will see them. And then we have the part where we show how we're working with the application of standards. So here we show how have we interpreted the standards we've been using. And also this builds on a framework that is nationally for several authorities, but I think we are the only authority so far that's really been testing it on several specifications. But the specification is one thing, but what is it that really makes it standardized? How? Because this is the way of working. How will we look at digitalization and the goal in the same way? When Boverket was working with detailed planning, they do it from the legal way, and they want to make sure that all the legal stuff is in there. When we talk to Lantmäteriet, we want to make sure that this is really good data, and that for this innovation and everything, those should also be built in. And the best part we get when we work together. And from the way of steering authorities, That is only possible if we work together by free today. And that's this process is made to make that a way of working. Always work together, work with all the competences you need from the beginning to the end. Don't use a water flow and think that you will end up in the right way. Because if someone is on their desk at home and thinks, oh, I'll just work ahead and then I will sell it into the others, you will get into conflict direct. Because then someone has already in their head how it should look like. The information specification describes the structure and content, and it's a conceptual model, it's an information storage model, and there is an object type dictionary. If you want to know more about this, you should talk to Helen during the day. I'm only on this, cloud-free way of working with this. In the process, we have a decision to start. And when we take the decision to start, we want to know what are the benefits of working with this SIM? What are the legal aspects? So we get all the authorities who have a legal aspect on the data sets involved in the work. We don't want to lose something. How are the information security aspects from start? If we know that this is data that's not possible to share, we shouldn't start with that because that's hard enough anyway. How should this be financed? And not only the work with working with the specification, because that's one of our mistakes. I think we've done hundreds of specifications that have never been installed. So what we're looking for now is that we want an authority taking responsible from making the specification, trying it on data sets and implementing it. And we don't start until we have that, because that's waste of time and money. And the last one, future management. Who will be responsible in the future? And do they have the authority in their instructions to do it? Because otherwise it won't be done long term. In Sweden, we have so many good ideas that have been implemented in innovation programs and then been thrown away. And we can't afford that anymore. We need this to build a system that works. The next, we go into preparations, and then we make the stakeholder analysis. Who are all the stakeholders in this process? And that's a lot. We have the municipalities, we have the system developers, we have security persons, we have the persons who are supposed to build the house and the ones who need to use the data for other stuff, who could give us some good use cases. I could use it this way. So all those we put together. We make a working group. We establish a reference group or several reference groups either. We make contact with the system suppliers, and we make the time and activity planning. And from now on, it's just a project, the drill. And then we do the requirement collection. We start working with the specification. We do modeling, we do documentation. We create operating and validation rules. How should this be checked when it gets into the platform? How should the quality requirements look like? And how do the processes look? Do we have to change in the collection processes to make it possible? And working with the building the way we do now, we realize that the entire process within municipalities have to change, because they do not look at the building information as one information model for the entire municipality today. It's different parts in the municipality that will have to start working together to create the data set. And that needs new processes. We also do the information classification, and this is where we look at the aggregated try as well. And we do not have the full knowledge to do that. So we have help from the Swedish authorities working with the security to try the data. And that has been put into a process from now on and further. We do the test cases, and this is important. We need to test this. As I said, this is the first time we do this. We need to test it. So for the digital detail planning, we had 4 different specifications before we were done. We tried it, we put it out there, we got the claims, we did it again and put it together. And now we are in a quite stable way. So now we think we won't change it for 5 years, at least. Because what happens is when everyone connects and everyone uses the same, it will be really expensive to change. So how often will we be able to do changes in information models in the future? And I'd say we probably work in 30 years of loops, because it will be so expensive when everyone is connected. And this we also need to put in thought when we build the system. Manage the results and put bets. And then at the end, okay, now we should make a decision. Should we use this specification? And as all of you know, there's probably no person working in Lantmäteriet or anywhere else who can say, oh, look at the model and say, oh, this is the best model ever. So what we decide on is to see that have the process for the work been good enough? And if that process have worked, we should be feel safe to decide on the specification. So we just check, have there been disagreements and have they been solved? Are the requirements in the architecture framework met? Has it been a democratic process? Has the work been transparent, and so forth and so forth? And if the answer is yes, and no one is complaining, okay, let's go. And this, for the detailed planning, it took 2 years to go through this process. For buildings, we have probably worked 1 year too long. And that's had other reasons than this. It's also to finance and other things. This is for the information security. We can lose that. I think we work together. The results so far, we have the platform. It's been in work since 2021. Lantmäteriet is working as a coordinator. So we do the qualification. We put agreements to the producer and consumers to come into the platform to give data and to use data. Lantmäteriet also works as a data host, which means that on the task from the municipalities, we can store and share data for the municipalities. We didn't want to put it in another register because all the legislations around registers make it slow to use data, and also we get another storage. We don't want double. So we try to start working in the way we say we want to work. So everything is there, it's in place for the platform. We also, for the detailed plans, had some regulations to support the process to make this work easily. So Boverket had made a requirement that all new detailed plans should be developed as digital models. So that's by law from the beginning of this year. And also Boverket says that when you make the new detailed plans, they should be following the standardized compliance with PBL, the planning and building regulations, in a certain way. And the municipalities got the ownership of the Inspire, and Lantmäteriet says, okay, you have the responsibility, we will do the solution if you use a platform. Trick away. Another way of standardization is legalization, right? So this is the way a detailed plan looked before. It's the mapping part and it's a document. That's what we started with. This is a new way of looking at the detailed plan today. You have it, this is the e-service that Lantmäteriet has. You can go in and check later if you want to. You can see the detailed plan in the map, but you can also see all the different regulations on the ground, and you can get them in the row list like this. And you can also download the document, the description of the plan, the ground map, and other investigations if the municipality chooses to put it there. So now you can get hold of what do I need to know and where can I find it? And this is the point of getting your hands on the data. Yes, 5 minutes. Lovely. And this is another way of looking at the detailed plan. If you put it into augmented reality and you go out in reality, this is where you can build and where you're not allowed to build, if you just use those attributes for what you need. And you can also use, okay, how far from the houses am I now, and where am I allowed to build? This is when we use it as data instead of a PDC document. Put it into action. And as I said, we have done 2 data sets. Yeehaw, we now only have 198 left. So we're trying to build this factory of making this go faster. And we have a good help from other authorities who are now getting their hands on realizing, what are we talking about? What is this? and they are going to help us further. So we now had, I think, 10 different specifications on the way and upcoming. So what have we done to put standards in action? We've been working with legalization. That's one way of making a standard. We've been working with centralization. It's another way of working with getting stuff standardized. We have been using the resource models, which is a third way. We have been adopting the existing standards from ISO and CIS. But last and not least, through really hard work. This is so many days of work to get this through. Again, ask Helen. And one obstacle that I want to raise before I leave. Of course, we want to use the standards from CIS and ISO. But when we put standards into legalization, we cannot do that. We cannot copy paste and say, use this standard because of the business model for using standards, because we cannot put costs on the municipalities. So if they have to pay to get their hands on the standard, we can't point at it. So this is kind of a backward way of not getting use of good standards. Was that? Did you get that on my cracky English? Okay, thank you very much. I hope you got something to bring home to Australia, US, and so forth.
Okay, thank you very much, Malin. That's great. Does anybody have any questions? Does anybody have any questions for Malin?
Yeah. The issue of cost. So I work with the IEEE Standards Association, and of course that comes up also. You know, the pension society involved in standards, people say, but we got to pay to use it, right? And so, you know, that doesn't work for us, right? Even though it's like $50 or something like that. Yeah. So there are various solutions we're exploring in IEEE, including a sponsorship program where a partner can come and say, we're going to sponsor the standard to make it free for everybody. That comes at a pretty high price tag, but you know, sometimes the standards are of great interest in the commercial sector, and vendors are willing to do that. But for a national body, of course, the national body has access to the standards. And then in the US, I know, like they create profiles of a standard, and they publish the UML and the schema for it, which is permitted, you know, under copyright. And then, you know, users can build to that. They don't need the document itself. They can build, you know, to the schema. Yes. So do you see that as a solution?
Lots of parts in those standards framework are the perpetuation of the standards and being put into these kind of schemes and stuff. So yes, we do that. And we also tried the other one. Agneta worked several years ago for buying out some standards. So we have about 100 different standards are for free because Lantmäteriet has been paying them off. But we still say, okay, but this one and this one, you know, but it's two ways of doing it. So we should use standards as far as we can. And we need to look further into how can we get that. So,
okay. Thank you. Has anybody else got a question? We've got time for another one, so I've got one for you. You mentioned about data, quite rightly so, how much time you're taking to put it together. How do you manage to govern that data well? Because by the end, you're going to have, what did you say, 290 municipalities worth of data. How do you do your data governance?
From the way we've been putting the roles, the data governance is still at the municipality.
Okay.
Yes, and we just read the data, right. Sort of. So there is one responsible for the data instead of, otherwise we would have the municipalities taking care of the data in their way, and we would do it from a register way. And that's what we do not want to create.
Right. But when it becomes, when it comes into your platform, then there's obviously lots of operations to happen to the data and be created and used. Do you have your own internal governance for that part of the data journey?
Yes, we will keep track of the what have been in the platform during time. So that way we do. But we do not put any energy in doing quality work on the data. It should just be passed through.
Great. Okay. And then one final question I got for you really is you've got your final stakeholders are obviously the builders in Sweden and the contractors that are going to be building. What do they think of this brand new data world? Are they happy with what you're putting in place?
They are happy with what we put in place, but they are not happy in the pace it's being done. I mean, they wanted it yesterday.
Right.
So that is also one of the issues. Could we make a better joint venture with the private part to make this happen faster? Because it's always about money and regulations.
Right. So have you considered bringing them in as partners, or?
That's what we are considering.
Okay.
Yes.
That's great. Okay. Thank you very much indeed.
Thank you, everyone.
Thank you. Could I have your mic, please, Mark? So it's that one, the top one, yeah. Just stick it in your pocket, put it on. Okay, our next speaker, Lars is mic'd up at the moment. So we've heard a lot about obviously planning and in Sweden. Transport is obviously another big issue. Lars has come to talk to us about a platform for data exchange at the Swedish Transport Administration. Again, these are issues that I wrestle with in the UK about how we can help our citizens travel more freely around the country and make sure that they are able to go from one mode of transport seamlessly into the other. I'm guessing that's the sort of thing that you're going to be talking about, Lars. So thank you very much indeed.
Yes.
Okay.
Can you hear me?
Yeah.
Yeah, good. Okay. My name is Lars Flodman, and I'm going to talk about the platform that we use at the Swedish Transport Administration for exchanging data. The purpose of this platform is, as mentioned, it's to make data available to a lot of people. We have a lot of legislations that we need to share data and things like that. And we have had for over 8 years now a platform with an open API and so on for sharing data. A couple of years ago, we saw that that is a really good platform, but we need to make it a strategic platform in the traffic administration for sharing data. So we decided to do that and also to use it for more purposes. We now use it both internally and externally to share data. So we can use it both between different transport sectors within the transport administration. We have like road and railway for separate parts, and we have external users and everything like that. So we're using it all over the traffic administration at the moment. And one of the key important things is to make it easy for business systems to share their data. They don't need to add functionality for security or encryption, or making sure that sensible data is not going to the wrong parties and things like that. We handle all of that for the base system, so they don't have to implement that themselves. We have the possibility to both send and receive data. We have a lot of interaction with partners where municipalities and other companies send in data to the traffic administration as well. So we can do that as well in the platform. So it's both ways. And it's really important for us that the platform is user-friendly. We want to make sure that developers and business analysts and everyone interested in this data have all the information they need and can easily start using it. And of course, we want to have the ability to support any agreed standard. The platform itself is very dynamic and can handle almost any format and anything like that. So we build it in an open way. So that is very important for us. I'll come in a little bit more on that. But one of the key design strategies is that we don't integrate systems. We don't integrate system A and B. We publish data and we do data exchange, because you don't normally need to know if it's system A or system B that created the information about a train station or train position or whatever we are sharing. We want to make sure that we can exchange those systems as well without the consumers need to know that anything has happened. The only way they need to adopt is if we do anything else. For example, we have support for versioning of data. Data models change. If we add a new attribute in a model, the producer of the system can start adding a new object, but we have versioning, so the consumers, they can continue to use the previous version until they are ready to go up to the new one. So we don't have to change anything the same time either. So that's very good. When we talk about the information that we share internally and some open data that we share with a lot of users, we normally create a generic data model for that data type. And that is a big job normally to do that. And I see that we could do a lot better with governance of data models and things like that, and reuse, as we talked about in the previous presentation, to have certain information objects that is the same all over all agencies and everything like that. But I don't think that we're there yet. But this platform, we can handle data in any format. So it's not part of the infrastructure. It's more managing information. But we can also use, and we are using, a lot of different industry standards. We are using data messages, for example, for traffic situations and things like that through this platform. So we can handle a lot of different standards in it as well. So the platform is data agnostic. We can handle XML, JSON files, whatever. So it's very dynamic in that sense. No, this one was supposed to look a bit better, but I see there's some fonts missing. The idea here is that we have built this platform very similar to a concept that Gartner Group has introduced, like a digital integration hub, where we have different channels with different partners, with open web applications. We have mobiles and so on that can access the data depending on what classification we have on the data, if it's open data or if it's for a specific partner or whatever. And that opens up a lot of innovation. We don't want to build all these applications ourselves from the traffic administration. What we want to make sure that the data is available to all these channels so that they can build the applications. It's not something we want to do ourselves. And for example, you talked a little bit that transportation between different transport ways, like if you have a kick bike and a bus and you have the metro and so on. If you want to plan how to get from A to B, it would be really nice to have an application where I say, I want to go from here to here, like in Google Maps or something like that. And you get different alternatives depending on how you want to travel. And with this data, you can actually do that more or less. And kick bike information and things like that is something that probably will come into this data as well in not so long future. Another really important part of this solution is that we have a horizontally scalable storage solution inside it. So we can handle a lot of data. We have hundreds of transactions per second today in the system, but we can scale that to almost, how much we want to, because we scale it in a very distributed way inside the solution. And we also have an integration layer that is very easy to use for the producers of data, so that they can publish data to this platform in a simple way. They can keep track and know if the data, they can delete data if it's not valid anymore and things like that. So they can make sure that we publish only the data that they want us to publish. So it's like a data cache, but they don't have to care about accessing and different transport protocols and things like that. We handle all of that for the systems. Yes, as I said, we have implemented this and use it both internally and externally. And due to security regulations and things like that, we need to separate some data from other data so that we don't get aggregation risks and a lot of different things like that. So we have several instances of this platform on different areas in the traffic administration. We have one that is outward facing for consumers. We have one specific one with a higher SLA for business critical information, and we have internal with security related information as well. So we have different instances, but it's the same solution we use everywhere. So if we have like built a new functionality that is good, like a better caching or something like that, it can be used all over the traffic administration. The only thing that is specific is each data type that we put into it. There we need to do some things for it. But also there, we are working a lot on adding self-service and automation so that we can handle a lot of new different data types and things like that in a very short time. So if we don't need to have like a month of development, if we're going to add a new data type or something like that, we can more or less configure and generate code and deploy things for this to work. But we're working on making that even more efficient in the future. And I think that is really important for a platform like this to be able to handle changes in a simple way. It would be very bad if we start to put everything into one box and then we get jammed and can't do changes, for example. We need to make sure that we can handle the load from all business parts in the administration as well. We have a very simple API where we can query data as we use for the open API. You can query data, for example, if I want to know all train stations within 100 kilometers from here, then I can ask about that. And I can do a simple query where I can use geoquery questions as well to get out the data from that. I can use polygons and everything like that and draw like an area of a map and say all train stations within this I want to get. And I want to have everyone that has changed within the last 2 months or something like that. It can be used for streaming data as well. So if we, for example, we have train positions, for example, that we share. If I want to build an application that shows a specific train on a map, I can start to subscribe to that data with something we call service and event. So then I can stream that data out to the client and they can show that position in almost real time. So it's very useful and you can use it in many situations. So it's a platform that we have built more or less completely by ourselves inside the traffic administration. We are using MongoDB and document databases and a lot of good infrastructure components in the bottom to be able to handle all this data. But the functionality, the APIs and everything like that, we're building ourselves just to make sure that we can adopt them and make sure that we can handle any standard that's coming and make sure that we can handle new types of communicating and so on. As I also mentioned, we really want to be user-friendly. So we have also built a data portal where consumers can come in and read about the platform. They can see all the information that we have there. All information is not open, so we have also some parts that is available only for partners, but it's the same platform for open data as well. We haven't opened up the open data in this platform yet. It's still on the old platform, but we're going to do that in near future. So in here, we can see news about new data types that are coming up and everything like that, operating information. If we're doing system maintenance that might affect some parts of the platform or something like that, it's available there as well. We have all the data models, and data models are usually described both in text and in schemas and things like that, but it could also be like document specifications that is being used in certain areas and things like that. So it's also a portal that we have built ourselves, so we can adopt it to different standards on how to present documentation about the service. So the users can try it out very easy. They can just log into this portal and do a search for train stations, for example, and then they can add a filter. I only want train stations within the county or something like that, and they only get those. And they can add filters, so we can, if an object has 10 objects, attributes, you can filter out one of them if you're not interested. So you can speed up the data transfer by reducing the size of what's transferred online as well. So it's a lot of functionality that you can try out here in the portal so it's easy to understand how the data works. And that is both for developers and analysts and so on. We also have code examples, code examples and so on to be able to show how you do it, how you integrate, how we use our security solutions, which is mostly standardized with OAuth 2 authentication and things like that. We also have a forum where you can ask questions, where both the community and us can go in and answer and help anyone that has a question. So it's a platform where we can make sure that everyone can get all the information they need to use this. This is an image on how the test bench look, where you see the query that you write, and then you get the answer below in both JSON or XML, depending on what you want to. We can also show it in a more HTML table. And today, the solution is used by thousands of users building their own applications, and companies as well are building small applications. Some have them on their intranet, show when is the subway leaving from the office or something like that. It's used by many internal systems. We use this a lot for exchanging data internally at the moment, and we also use it in exchange with the external companies like train operators, vehicle companies, and so on. So it's used heavily in the traffic administration. We have more than 300 types of data objects in it today. So it's used quite widely. And we can set up new data types very simple, saving a lot of time and money for the administration. And you don't have to, as I said, build this integration logic in every system, handling different users and things like that. It's handled by us. So yeah, that was my presentation.
Thank you very much, Lars. The thing that strikes me about all this data that's being published, obviously going out there, is that if you have an incident on the transport network, everybody gets to hear about it very, very quickly. So I suppose that's the downside, but thank you very much. We've got time for a question or two. Does anyone have a question for Lars? Scott.
So you described having that test bench.
Yeah.
Who is the test bench available to?
The test bench is available for everyone. So you could log in and don't have to log in as well. You can just go in and use it today. The open part is at another endpoint today, but in a few months, we will have that one open. If you go into another address, you can do the same thing today. So it's open for all the open data we have. Anyone can go in and test it out. So if you want to build your own application, go ahead.
Okay, I'm going to play.
Yeah. So we're going to try this afternoon, Scott, are you? Okay. Okay, I've got a question for you, Lars. You mentioned about being able to track trains and sort of near real time. Have you done anything more ambitious in that sense? Are you able to track traffic congestion in real time or anything?
Yeah. We have that kind of data as well, where we have the traffic flows and things like that. That is published today from our systems that's measuring that on the roads, and that's available in almost real time in the API.
So you've got IoT sensors out on the roads and stuff. Yeah, that's brilliant. Okay, and then one final thing from me. So how long have you been making this data available?
The open data we have had in this API in different versions for over 8 years.
8 years. Okay, that's quite a time. And has that sparked a lot of innovative interest from companies and things? Yeah.
Yes, there's a lot of interest, and this data is used by a lot of companies, and they want to build applications. And there's also a lot of companies that come and want to see how we have built this and so on as well. And of course, we are happy to share that information as well if anyone is interested to see how we have done it.
Okay. And I suppose that brings back the loop as well. So the more people innovate, the more thirst they have for new data sources. So
Yes.
are you seeing that as well?
Yes, absolutely. And there's coming new regulations also on a EU level about sharing more and more data. So that is also regulated, that we have to do this. But we also see that since it's so easy for us now, we can also do it if someone is asking for it, if it's not anything security related or anything like that.
That's great. Okay, thank you very much, Lars. Yeah, that's brilliant. Thank you very much.
Yes, thank you.
There's a mute button on the top. Okay. Should be tough, mate. Yeah, I think. Yeah. You're on. Excellent. Okay. A slight change of tack now. We've got Paul Lacey, who's a principal geospatial data scientist. He comes from the UK, and he's come to talk to us about how can reference architectures enhance interoperability. Now, interoperability is something that I think will be more and more important in the future as we begin to aggregate big data together to look at the issues that society confronts. So I'm really interested to see how we can improve our interoperability just by taking a closer look at our architecture. So thank you very much, Paul.
All right, thank you. All right, thank you, everybody. I'm Paul Lacey, and I work for the UK MOD as part of an organisation called the Defence Science and Technology Laboratories, which are the research arm of the UK military. But today I'm here representing the Defence Geospatial Information Working Group. So I'm going to tell you a little bit about who DigiWig are and tell you about the work we've been doing on developing the DigiWig geospatial reference architecture. So first of all, DigiWig, who are we? Well, we're a 22-member nation, some of which are NATO, some of which are non-NATO, and you could probably, most of you there would probably recognise your flags on that nice wheel there. And the aim of DigiWig is to sorry, one moment here while we just correct some technical issues. Okay, so back to the brief. Yeah, so the vision of DigiWig is to help improve the interoperability of geospatial data and information services across the multinational defence environment. And we do this in a number of ways. The first way is we exploit standards that have already been developed by the international community through organisations such as ISO or OGC. And we look at those and we build military profiles of those. So we look at them and we say, how can these be best implemented within the military environment to meet our requirements? And then in addition to that, surprise, surprise, we also develop some of our own standards as well. So the military domain, I mean, as with any domain, it's quite a complex domain, but within the military, especially in the multinational domain, there are lots of different organizations who all want to share their data and make it available to the end user. However, there's lots of different data types out there and proprietary formats, you know, so how do we get around that? We actually use community agreed standards, such as those developed by DigiWig and yourselves, to do this and to help achieve interoperability. And this as a way forward is good, but it does have its problems. And there's that horrible word, however, or a but, if you like. It's always there. It's never quite as simple as it should be. So one of our main problems is that standards themselves can be quite complex. You know, even for a relatively simple function, you write a standard and it turns out to be 15, 20, maybe even 80 pages long. And that's quite a lot for somebody who's not familiar with the domain, maybe, to understand what that standard does, how it works, and how it fits into what they want to deliver. And also part of the complexity is how we deliver standards to the end user community. We've got those, first of all, we've got those big standards documents themselves, but then in the military community, what we do is we kind of compound that by making a list. So in the UK, we've got a document called the Joint Geospatial Doctrine, which tells the capability planners and developers which geospatial standards they should use. And essentially it's a list of 200 standards. So you multiply that by the number of pages in a standard, which, you know, if you're lucky, it's 20 pages. If you're unlucky, it's 80. So you're giving the developers effectively, you know, between 3,000 and 10,000 pages to read through and understand what standards they should use before they've even started thinking about what the capability is going to look like and what it's going to provide. So we needed a way to get around that and to actually democratize the use of standards within the military community. So what we did in DigiWig is we actually looked at the wider community to see what they were doing and how they were better enabling the use of standards to make interoperability a real thing. And one approach that we found was actually it's being used by one part of the military community. It was being used by the imagery intelligence analysts who had this architecture which showed what standards they use and also the functionality that they provided, and linked those to actually systems and softwares. And we thought, actually, this could be useful for the geospatial community. And the approach they had was really, it was a reference architecture. So what is a reference architecture? Well, go to Google, you can, as with anything, you can find 100 different definitions. This is one definition I quite like from the Australian Bureau of Meteorology. Now, I'm not going to read it out for you. You can all read it as well as I can. But essentially, it provides a framework which links standards to system capabilities, to roles, to functionality, so that actually a reader can understand where those standards are going to be used and how they're going to be used, and what software is going to be used to enable that, and actually what roles and functions I need in place to enable those standards to work within a system. And this is all described in a reference architecture. So what are the benefits of this approach? Well, in the UK, we have a thing called the golden thread, which links your starting point to your end point. And if we take standards as the start point, it sort of joins up the standard with the functionality, with the software that's going to provide that functionality, with the capability that the end user is going to use to do their work. So it provides that thread so that a developer or a systems planner can look at the document and say, actually, look, I want to disseminate geospatial data to the end user. What do I need to do? So what it does is says, here are the standards, and here's where they sit in the context of the system and how you should be able to go around and actually utilize those standards to build your system to disseminate that geospatial data. And what's this do? Well, it makes standards more understandable and relatable to the planners, to the developers, especially the developers, because quite often in our community, the developers aren't necessarily au fait with the geospatial world and the geospatial standards used within there. So this actually tells them, actually, this is what that standard's all about, and this is the kind of functionality that it's going to provide. So I know I should be using this in my system. And what's this do? This leads to other tangible benefits as well, such as improved interoperability, accelerated development, which in turn reduces costs and development time. And also it improves the quality of the system and the data used by that system as well. So back to the actual DGRA itself, the DigiWig Geospatial Reference Architecture. The approach that we decided to use for this, as I said, we looked at the image community and their approach, and they used to develop their architecture, they used a bespoke approach. But actually, DigiWig being a standards organization, we wanted to use a standard approach to do this. So what we did is we looked at ISO, and ISO had the perfect standard there. It was ISO 10746, which is the reference model of open distributed processing. Now, the reason we chose this actually because it was actually quite simple to use and visualize. And actually for our military community, we like simple, believe it or not. It's easier for us to understand. And at the heart of the ISO 10746 standard was actually breaking the system down into these 5 architectural viewpoints: the enterprise viewpoint, the information viewpoint, engineering viewpoint, computational and technology viewpoints. Now, all these viewpoints look at the system from a different perspective. They're all linked, but they're not necessarily sequential. So you don't go from one to the other. So they all tell you a different aspect of the system depending on what you need to know. So I'm just going to go through and tell you how we've gone about looking at these viewpoints in the DGRA. So first of all, the enterprise viewpoint. This defines the purpose, the scope, the policies of the system. So in terms of the DGRA, this is basically to enhance the discovery, access, and dissemination of geospatial information across that military domain. And this is going to be enabled by using a service-orientated approach, using a set of community-agreed standards and exchange formats, and also sharing metadata across that enterprise as well, so that we all know what the data and services are that we are providing and how they're going to help you. Now, also part of the enterprise view is the DigiWig standards model, or the DGRA standards model. And this is where that it's the high level view that shows how the standards relate to the functionalities. So as you can see there, there are a number of different components to this, each containing various standards. So you've got a manage and store component, you've got a process component, a collect component, a disseminate, and a consume component, each with standards that enable different aspects of that component. So it gives the reader quite an easy overview and summary of actually what DigiWig standards do and how they can help you in your system. Now, in addition to that, you can notice there's several different colors on there, from the orange, green to pale blue, and they actually show the reader actually whereabouts we in DigiWig are in the development of standards, of those particular standards. So the orange are ones that are currently being worked on, the greens are standards that are completed and available to you, and the blue ones are ones which we are considering developing profiles for in the near future. Now, the information view, this describes the data that's going to be used within the system, and it describes the various different models. So it describes the vector data model, the metadata model that we're going to use, the imagery models, and the portrayal models. They're the 4 main components that models that we're using at the moment, but there is also inbuilt into the DGRA the flexibility to add more models as we go forward. So we might want to add a sensors and observation model to that as we go forward and develop the DGRA. Now, in terms of in addition to the data models, there's also the various maintenance processes and data exchange formats that we use to share the data between those models and actually maintain them as we go forward. Now, the engineering view, this describes the system components and their relationships, functions, and also how they relate to the various roles that you need within the DGRA. So on the screen there, you can see, I would hesitate to say, a fairly simple model showing the various engineering components that are used within to disseminate data. So you've got a collection system at one end that goes into a data store. That data store then can be used to create geospatial web services. Those web services are in turn put onto a registry so they can be discovered. And because they're in that registry and can be discovered, an end user, be they a human or an automated system, can interrogate that registry and pull out the services and data that they need to do their day-to-day work. And that's a sort of very high level view of a system for disseminating geospatial data. Now, the computational view, this describes the various systems interfaces. So we've got all those components there that I showed you in the previous page. Well, how do those components talk to each other? What are the interfaces between those components that make it work? And how do they relate to standards? So in the DGRA, we say, we've got an interface here. It's called the Web Map service. And actually, this is a service for visualizing map data to a human user. And these are the various functions or interfaces that it uses to do that and that you need to be aware of. And it breaks those down. And actually, this is just a high level view, but the DGRA just describes those in more detail. Not as much detail as the standard, because the reader can always go to the standard if they want that more that greater detail. This is just to give them a high level appreciation of what those interfaces are and how they relate to each other, so they can start to plan their system and decide what their system is going to actually look like and contain. Okay, the next view is the technology view. And this actually relates software to the standards in terms of their compliance to those standards. So a user can actually look at the technology view and say, actually, there's this software here that is compliant to these particular standards that I want to use within my system. Now, at the moment, the DGRA doesn't have a technology view. And the main reason for that is that in order for this to happen, you need to have a robust compliance and conformance process in place. Now, DigiWig doesn't have that at the moment, but it's in the process of looking at that and how we're going to provide that. So in the next version of the DGRA, we will have that fully complete technological view that includes compliance and conformance. The DGRA will also look at future concepts and technology. So it will look in various epochs from 1 to 2 years, 3 to 4 years, 5 years plus, and sort of tell the reader, actually, these are the technologies and standards that are associated with them that you need to start thinking about when you're developing your system. So a person isn't just looking at the here and now for the system, they're actually thinking about future interoperability and what they need to be considering further down the line and how that system might develop and mature over the years. DGRA also has wider relevance. So as we've been developing the DGRA internally with DigiWig, we've also been talking to other organizations as well. We've had some very fruitful conversations with the OGC and Scott in particular, and they like what we've done with the DGRA, and they've used that to inform the work that they've been doing as part of their own reference architecture as well. NATO, they're also interested. We're talking to them about how this can be used to influence the development of their future network capabilities and standards capabilities. And also individual member nations are also starting to adopt it. For instance, the UK MOD has also taken the DGRA, even though it's only just about to go out to ballot to be ratified, and included a version of that within their own policy to influence the development of the capability within the UK. So that's just a brief summary of some of the key points there that I've talked about today. If anyone's got any questions, I'll be more than happy to answer.
Thank you very much, Paul. That was great.
Thank you.
Any questions for Paul? I've always got questions. Was anyone else got a question for Paul? No. You mentioned your reference architecture, and it's obviously it's quite difficult to get that big group of countries around a table to put that together. Are they all up with it? Are they all quite keen to follow this path that you're setting? Or
yes, is the easy answer. But actually, before we got to yes, it was a bit more difficult. We had to do a lot of convincing. Yeah, because DigiWig's been going for 20, 25 years, and I've only been a member for the last 15 years. Yeah. So people are quite set in their ways.
Yeah, that's what I'm trying to get at, right? So
people were quite set in their ways. So we had to convince them actually that this approach, would be useful and would be worthwhile, because actually it's not a quick and easy thing to go away and develop a framework like this and to develop all the contents behind it. So we had to, convince them. So we wrote a white paper, briefed it to the community, and actually did lots of question and answer sessions. And actually, by the end of it, people were on board. They're actually, I can see the benefit in doing this. There is actually.
And what stage are you at the moment? Have you implemented the reference architecture at all, or are you still working on that?
The final draft is now complete.
Yeah,
and it's imminently about to go out to ballot by the members.
Right.
Yeah.
So the benefits that you're going to see in interoperability, you're not going to see them for a little while yet until it's been implemented. Is that right?
Yeah, some of the real ones, yes. But as I said, we've been working with the wider community, so it's already starting to have some tangible impact there. So, it's been used by NATO, it's been used by the UK MOD, and the fact that it exists in there, it's actually starting to have some effect on the way we're developing things. It's already informing what the next generation of our geospatial dissemination is going to be.
You probably need to have you back, and then we can see what benefits that interoperability. I can see on the screen that there would be massive benefits to be had. So I'd be really interested to find out what they actually turn out to be. So, is there any questions for Paul? Yeah.
Hi. Thank you.
In the computational view, you mentioned WMS is WMS the only protocol that is supported in the computational view? I mean, it seems they're actually in the engineering view. You could map standards to like every one of those interfaces.
Yes,
right?
indeed.
Right. So when you get to computational view, we've got one.
That was just an illustrative example of how we're describing it within there. There are numerous standards in there for that view, and at the moment it's focused around those web service standards. So you got the web feature service, web processing service, the CSW as well. So you've got a whole different number of various interfaces and standards represented within that computational view.
Good. Thank you very much, Paul.
Right. Thank you
very much.
Thank you for inviting me here.
Yeah, no problem.